All right, this is part 2 of the Illuminate review for test 7. So let's look at question 5. The location of train A is shown on the graph to the right. 2 more train tracks are planned. One is parallel and one is perpendicular. The new tracks will each pass through this point, 0, -2. Which equations would describe each of those tracks? So 2 equations are correct. Remember, one is parallel. Parallel means one has the same slope. One is perpendicular, which means you have to change it. So we got 2 to do. Change the slope. First, let's find the slope. So I'm going to pick 2 good points. There's one and there's one. So it's rise over run. You have 2 choices. You can write these 2 points down. This one here is -1, 0. This one here is 0, 2. You can plug them into the slope formula, y2. You can do it either way, minus y1 over x2 minus x1. Either way you would like to do this, okay? Or you can do rise over run. Rise over run is we went up 2 and over 1. This is a positive slope, so my slope is 2. Okay, you get the same answer if you plugged it in this formula. All right, now for parallel, I use the same slope, but that's the point it goes through. So you have 2 choices here. You can recognize that this is the y-intercept. So you know your answer is y equals 2x minus 2. That you could recognize. If you do not recognize that this is the y-intercept, then you could label this x and y and plug them in and solve for b. I'm going to show you how to do that over here. So remember, it's y equals mx plus b. We're solving for b. So I'm going to erase the m because we're doing the same slope and put a 2. And then I'm going to erase the x and I'm going to put a 0. And then I'm going to erase the y, and I'm going to put a -2. And I'm going to solve. That is 0, so you get -2 equals b. That's how I got that. So this is one of your answers. Your other one is perpendicular, which means I have to take this slope and change it. So I have to make it negative. And then 2 is the same as 2 over 1. And if I flip it, it becomes 1/2. Then this is my other slope, -1/2. It's going to have the exact same y-intercept. So this equation is y equals -1/2 x minus 2. These are my 2 equations. So, first one is D. The second one is B. Those are my 2 choices. All right, number 6. A homeowner wishes to put a fence around a space in her yard to create a dog pen. The space that she wants to fence in is shown below, where each unit on the graph represents 1 foot. How many feet of fencing will the homeowner need to build the dog pen? So if you remember from class, every line that is horizontal or vertical, you can just count. So 1, 2, 3, 4, as long as they are evenly spaced. 1, 2, 3, 4, 5, 6. Now I can count. 1, 2, 3, 4. This is 4. Same thing with this way. It's 1, 2, 3, 4. As long as it's counting by ones, you can just count like this. So it's 1, 2, 3, 4. Let's count this bottom one. 1, 2, 3, 4, 5, 6, 7. The only one you cannot count is the slanted line. You must use the distance formula. So 3, 4. and 6, 0 are my 2 points. This is x1, y1. This is x2, y2. It doesn't matter which one you label, it will still work out. So square root. So remember the formula is x2 minus x1. So it's 6 minus 3 squared plus y2, 0 minus 4 squared. Put this into Desmos. Let's go look. So I'm going to say 6 minus 3 squared and 0 minus 4. Make sure you copy it exactly. And the answer is 5. Please go and look and make sure you've got your squareds, your minus signs, everything that needs to be there. All right, so we now know this side is 5. We're finding a perimeter, because we need to know how much fence to buy. How many feet of fencing will she need to do? That's the perimeter. We add all sides. So that means we have 1, 2, 3, 4 sides. So we have 4 sides. Let's add them up. 4 plus 4 plus 5 plus 7 equals, put this in Desmos, 4 plus 4 is 8, 8 plus 5 is 13, 13 and 7 is 20 feet. Put it in Desmos and make sure you got 20. Don't just do it all in your head. All right, going on to number, what's this one? We got a lot of things to do in this one. Let me make it a little smaller so we can see everything. We got 2 triangles here, it looks like. I'm going to highlight one. Here is one. That's one triangle. And that is A, can't read these, E, F, G. When you're reading triangles, you read them in order. A, E, F, G. I'm going to write that inside here. A, E, F, G. Now we have a bigger triangle. Let me highlight that one. There we go. I'm going to do it on top so we see it. And there's this one. This triangle is A, B, C, D. Okay, the big one is A, B, C, D. So Ashley determined the perimeter and area of a rectangle AEFG and the rectangle ABCD. She then made 3 claims about the rectangles. Determine whether each claim that Ashley made about one or both of the rectangles is true or false. All right, so we're talking about perimeter and area. So let's find those first. Okay, so let me get my color. We're talking about triangle. We'll start with the small one. A, E, F, G. The good thing is they're vertical and horizontal. We can count. So I'm going to make them a little bigger so we can see better. Now, if we notice, each square is 2. 2, 4, 6, 8. So we have to count by 2s. So 2, 4, 6, 8, 10, 12. This is 12. Same thing with going up. They're counting by 2s. This is 2. This is 2, and this is a rectangle, so that means this one is 12. So let's add them together, all 4 sides. 12 plus 12 plus 2 plus 2 equals 28. Oops, sorry about that. Need to slide it over a little bit. 28. Okay, all right, let's find the area of the bigger rectangle, which is A, B, C, and D. All right, I'm going to erase this. I don't care about that one. I'm going to erase this one for now. Let me go ahead and put the yellow back in there, only because the bigger one is not 12. All right, so let's count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18. So this is 18. That means this is 18. 2, 4, 6, 8, 10, 12, 14. If this is 14, this is 14. Let's add them up. So we have 18 plus 18 plus 14 plus 14. So we're going to add them up in Desmos, and you should get 64. Okay, so now we know the perimeters. Let's see, what else do we need to know? Let me look at our questions. The perimeter of rectangle ABCD is 64. That's true. We just figured that one out. The perimeter of rectangle ABCD is 3 times bigger. Ooh, 3 times bigger. Well, let's look at both of these. They're saying this is 3 times this. So we're going to say 3 times 28, does it equal 64? So I don't know. Let's see. 3 times 28 is 84. This is 84. This is 64. So is triangle AEFG 3 times bigger? No, it says rectangle ABCD is 3 times bigger. False. Then the last one is the area of rectangle AEFG. All right, so area of a rectangle is length times width. Some of you told me base times height. So let's go back to this. It'd be 12 times 2. So this would be 12 times 2, which is 24. False. It's not 48. Okay? All right, problem 8. Right triangle ABCD has vertices. What are the coordinates of the midpoint of a hypotenuse? Oh, good. Maybe we haven't talked about a hypotenuse yet. Maybe we have. Let's plot these. I can just plot them right here. So I'm going to go 9, 0, 0, 12, and 0, 0. So I can connect. Let me use, I'll use a highlighter. Connect. Oh, and then these connect. All right, a hypotenuse. There is a right triangle here. The hypotenuse is always across from the right angle where the box is. So what are these 2 points? This is 0, 12. This point is 9, 0. Find the midpoint. Okay, I'm going to label this x1, y1. This one is x2, y2. Using our formula, x1 plus x2 over 2, comma, y1 plus y2 over 2. Let's plug these in. x1 is 0. 0 plus 9 over 2. The other one is 12 plus 0 over 2. All right, if you put these into Desmos, you will get 2 possible answers. 9 over 2, 6, or 4.5, 6. These are your choices of answers that you might get. Okay? All right, I'm going to go on to part 3 so that I have enough time to talk about the last 2 questions. Again, don't forget what a hypotenuse is.